In this video, we are going to look at the conditional statement and some variations of that, and then something known as Demorgan's law. So, when we talk about a basic conditional statement, in terms of how we translate it, we can say it's something such as an A, single arrow, B. So, for example, we could say, if the girl was given the right shoes, then she can conquer the world. What a converse does to that statement is it switches the B and the A around. So it would say something like, if she can conquer the world, then the girl was given the right shoes. On the other hand, notice the inverse. It keeps it in the same order as your original conditional here, but it negates everything. So it would say, if you do not give a girl the right shoes, she cannot conquer the world. The contrapositive turns it all around and negates it, so it would say, if she cannot conquer the world, then the girl was not given the right shoes. And then finally, the biconditional, notice it becomes a double arrow instead of a single arrow, and what that means is you're going to see the phrase if and only if show up in between the two statements. So it would say something such as, give a girl the right shoes if and only if she can conquer the world. So now, what I focus on is if the word has the prefix con, that means to turn around. So if it's just the converse, you simply turn it around, whereas if it's the contrapositive, you're going to turn it around and do the opposite of making it positive. You're going to make it negative. On the other hand, when it's an inverse, you're going to leave the order the same, but you're going to make them both negative. And then, like I mentioned, the biconditional is your double arrow. Okay, so as we look at this example, if we are given the statement that says, oversleeping can cause or causes me to have a bad hair day, so you can think of the oversleeping, that's like A, causes me to have a bad hair day is like your B. So if it says, if I do not oversleep, so that's like saying the negative of A, then I do not have a bad hair day. So notice what I did in this case is the order stayed the same, but I negated everything. And anytime the order stays the same, but I negate everything, we call it the inverse. On my next example, it asked me to find the converse of this statement. So remember, converse, con means to switch around. That means the negation of Q will come to the front, and the negation of P will go to the back. It simply switches it around. All right, in my next example, it says we are given the statement, if our firm does well this quarter, so we can think of that as like our P statement, then we will get bonuses, so that's like our Q. So then they give me the statement, if we get bonuses, so that's like pulling the Q to the front, then the firm did well this quarter. So again, that switched the order, which is con means to switch, and we didn't negate them, so we're switching them, just switching the order, so that would be the converse. Now, sometimes they may ask you to look at a truth table for some given statements to see if they're logically equivalent. So notice we're looking at two statements, P and Q, and so here are their starting values in our truth table already set up. And then we're going to compare it to, we're going to look at the conditional of if P then Q, and then we're going to compare that to the negation of P and the negation of Q. So in this column here, all I did is I'm going to label it as the negation of P, and I took each of the values and I just negated them. So true became false, true became false, false became true, false became true. So then in the next column, I'm doing the negation of Q. So true becomes false, false becomes true, true becomes false, and false becomes true. So now, in my third column, I am thinking of the conditional, if P then Q. And with the conditional, remember that it's only false when you have a true then false. So as I look at the first, I have a true followed by true, so that would be a true. On the second, I have true followed by false. That is when your conditional is false. All right, if we have false first, then true, that is true overall. If we have false first, then false, that is also true overall. So remember, the conditional is only false when you have true, then false. All right, as I look at my and statement in this column, I'm going to be comparing these two columns here. And remember, and is true only when they're both true. So when I look at this first row, let me switch colors real quick. Notice they are both false. So and would be false. On the second row, true is only, or and is only true when they're both true. They're not both true, so that would be false. On the third row, and is only true when they're both true, so that would be a false. And finally, on the last row, and is only true when they're both true, that would be true. Now, in order for these statements to be equivalent, they have to match all the way down the table. And so if you look, they're not matching on the first row and they're not matching on the third row. So overall, we would say they are not equivalent. They have to match exactly. All right, finally, it says use Demorgan's laws to write an equivalent statement without parentheses. What happens on Demorgan's law is when you try to distribute what we call a negation symbol, when you try to distribute it, so that would become a negative P, what happens is it flips the symbol in the middle. So the and symbol actually flips over to become or, and then when you negate that, the negative of negative Q would become just a regular Q. So that would be the equivalent based on Demorgan's laws. And you could actually do a truth table to prove it. Now, in this last one, it says use Demorgan's law to write an equivalent statement using parentheses. Okay, so we know, we just said with Demorgan's laws that when you distribute a negative, it's going to flip the symbol in between. So if the new symbol is an and, we know the original had to be an or. And then we just have to ask ourselves what needs to fit into this place and this place to give us our equivalent. So if we need a normal P, then the only way that's going to happen is if we started with a negated P, because when you go to distribute, a negative negative becomes positive. Again, the or would flip to and then over here we would just simply need a Q, because when you distribute the negative or the negation, it becomes the negation of Q.